In this section, we're going to learn about the different types of errors and exceptions that are built into Python. We'll also explore how users can define their own exceptions, as well as taking a look at some libraries that help us when testing our code. Now, I can say with 100% certainty that when you go through a coding journey, for example learning Python, you will run into errors. Naturally, we all make mistakes, and we're going to be presented with error messages on the screen that the Python interpreter encounters. Now, don't be alarmed when you see errors. In fact, this is just part of the journey. It can be disheartening at the start when you keep running into errors, but it can also be disheartening for experienced coders who are trying to find a needle in a haystack when it comes to debugging their code. Debugging essentially meaning trying to correct the errors that are observed. Now, as you go through your journey, you will get better at identifying what different types of errors are and how they can be resolved, but this comes with experience. In this section, we're going to learn about some of the common errors and how we can write code in order to handle these errors so that they don't cause onward issues in our programs. So the first thing to note is that when we code in Python, a program or a script will terminate as soon as it encounters an error that isn't foreseen. And these errors, broadly speaking, can be classified into two different categories. We first of all have syntax errors, and I'm sure you've seen this error along your journey so far. So for example, if I were to do a simple if statement that states if 5 is greater than 3, and then on a new line I print hi if this condition is true, you can see that we run into a syntax error telling us that we have invalid syntax. And this is because we've forgotten to put the colon in our if statement. So with the interpreter recognizing that there's an error in the syntax, we can now go back up, debug our code, and therefore put a colon, and now when I run this code, we do indeed print hi to the screen, and we've corrected our syntax error. So this is the first type of error that we can run into, and it's caused by some form of mistake with the syntax that we're using. Now, the second type of error that we can run into are known as logical errors or exceptions. And what this means is that our syntax is okay and there's no syntax error, but the error occurred when running the program, and these are called exceptions. So let's quickly see some examples of some common exceptions that you may have encountered so far. For this example, I'll quickly create a function called divider, and I'll pass two parameters into the function header, x and y. And what this function will do is simply return x divided by y. So if I now call upon the divider function and pass in the integer 10 as the first argument and 2 as the second, we return the answer 5, just like expected. But what if the user of our function passes in something that isn't expected? For example, if we pass in 10 as the first argument to the divider function, but then pass in the string 2, you can see that we run into a type error, and it's telling us that we can't divide an integer by a string. So what has essentially happened here is that Python has created an exception object for this specific scenario. Now, these types of errors need to be foreseen in our program because a user may pass in an object that doesn't work with the specific syntax that we utilize. So we need to handle this properly and try to ensure that this type error is picked up in our code before terminating our program and throwing an error to the screen. And we'll see how we can do this shortly. So this is an example of a type error. If I were to call the divider function and pass 10 as the first argument and 0 as the second, you can see that we get back a 0 division error. And the error occurs because we're trying to perform a division by 0, which we can't do. But what if a user passes in 0 to one of the arguments? The interpreter would run into this error whenever it's observed, so we need to try to capture this error before it happens. Another type of exception that you may have come across is when we try to index a list. For example, if I create a list called my_list and set this to integers 1, 2, 3, 4, and 5, if I try to call the value at index position 5, which we know doesn't exist here because we've got index from 0 to 4, when I try to access the value at index 5, we run into an index error, telling us that the list index is out of range, which we know it is because there are only 5 elements in this list, and we know that indexing starts from 0. So we'd want to handle this type of exception in our code accordingly. And let's just cover one more example of an exception that you may have come across. If we had a dictionary called my_dict, and we set this to two key value pairs, the first key being A, with the integer 1 associated with it, and the second key being B, with the integer 2 associated with it. If I try to access the key C from the my_dict object, which is a dictionary object, you can see that we run into a key error, telling us that C doesn't exist as a key within this object. So there are lots of different built-in exceptions that can be raised when the Python interpreter identifies an illegal operation. We've seen a few examples here, but we can view all the built-in exceptions using the built-in locals function, and we can type something as follows. If I were to put locals with a set of parentheses, and then pass in a list with the string dunder built-ins dunder, and then wrap this in the dir function, we're able to list all of these exceptions as strings. And you can see here we have a long list of exceptions. You can see that we have assertion errors, attribute errors. If I look down, we have environment errors, import errors. We've seen the index error, key errors, runtime errors, lots of different types of errors. Now these are obviously the built-in errors that Python has when you download Python onto your machine. But users can also define their own exceptions, and we'll see how we can do this later on. Now, in order to avoid our program running into these exceptions, we need to handle them accordingly. And in the next video, I'm going to show you the syntax that we can use to identify exceptions before they happen, and then tell the computer what to do about those exceptions as and when they're observed. So I'll see you in the next video.